The voltage difference between the intracellular space and the extracellular space when a neuron is in its non-activated state is the cell's resting potential, which is around -70 millivolts. The resting potential is the electrical charge the cell has when it is resting and not stimulated by any open ion channels. The electrical charge inside the cell is more negative than outside the cell due to the high level of sodium ions outside. Inside the cell are more potassium ions, but also negatively charged proteins. The cell membrane is filled with ion channels that allow ions to enter the cell when stimulated by an actual potential. When the cell is in its resting state, the channels are closed but still leaky, and ions will move in and out of the cell. The membrane is more permeable to potassium ions than sodium ions, and therefore, more potassium ions will leave the cell because of the concentration difference created by the low level of potassium outside the cell. This will cause potassium to diffuse out of the cell. The potassium ions are brought back inside by the sodium-potassium pump that throws out 3 sodium ions and takes in 2 potassium ions with the help of ATP. The voltage difference between the inside of the cell and the outside will allow the cell to receive electrical signals known as action potential, where the sodium channels open, letting in positive ions and thereby making the intracellular space more positive.